Hey all. So we're going to finish our conversation about inverse functions. If you haven't looked at the calendar already for this week, I will give you a couple heads up. One, we've got a short week, we've got MEA. So you're just going to have this one lesson. You'll have a short quiz tomorrow, and then you will have a workday on Wednesday like normal. If you have questions about that calendar, please let me know. The other important thing is that your next test is next week. So I've opened the Zoom section already, so if you want to meet early about that, I strongly encourage you to do that. And that'll be available for all of the days that we're in school this week, as well as going into next week before the test. So let's take notes on our last section and talk about inverse functions. Now, one important thing about inverse functions that I do want to talk about, or in this case, inverse relationships, is we mentioned several times in the last lesson as well as the last test, is that inverse functions only occur with one-to-one. However, we can look at this parabola here and we can graph an inverse relationship. It's not a function. It's going to fail the vertical line test, but it is a relationship. And the important idea here is that the graphs of inverse curves are reflections across the line xy. So if I sketch in the line xy here, which is there, then if I wanted to sketch the graph of this, I would take this and reflect it over this line. Now, some things are really helpful in terms of drawing this curve. One thing that I always find helpful is that points that are on the line are on both the function and the inverse. So I already know 2 points that are going to be on this inverse curve. We're going to have one right here and one here, since they are on both. The next point I'm going to plot is this. When it flips over, it's going to be up here, because we're going to have the same spaces down. So 1, 2, 3, 4, 5, 6, 7, 8 little blocks. So this point here becomes this one here, which we might call A prime. The next ones that I would graph are these, the zeros, because it starts at the 0 on the x-axis, becomes a 0 on the y-axis. And so we have our positive and our negative. And that gives us a good spacing of the points that we would want to sketch in. It's going to be the same shape because it's a reflection, but it is going to fail the vertical line test. We're going to have a parabola like this. So again, there are inverse graphs, there are inverse relationships, but not necessarily always inverse functions. So let's talk, though, about how to find inverse functions. Here we have 2 different problems of different challenge levels. The first one, find the inverse function of f of x is equal to 2x plus 10. So the first thing that you want to do is you want to switch x and y. This is something students are pretty used to. One thing that is helpful if you're stuck is start off with writing f of x as y, which makes it a little bit easier to then flip it where you have x is equal to 2y plus 10. Now, the next thing you're going to want to do is you solve for y. So we're going to take this new equation here and we're going to solve for y. So I'm going to subtract 10 on both sides. So then I have x minus 10 is equal to 2y. Then I'm going to divide by 2, and you could write it as x minus 10 over 2 is equal to y. You could also say 1/2 x minus 5, however you want to write it. Once you have y by itself, that's awesome, you're done. I would recommend that you rewrite it as an inverse function. As an inverse function, so f of -1. So f inverse, sorry for that not very neat handwriting, let's clean that up. F inverse of x is equal to x minus 10 over 2. So just neatening up our final answer. This is the one that students generally feel very comfortable with. I do want to do a more challenging problem as well. Here, we have f of x is equal to x over x minus 3. And this becomes more challenging because when we switch around our x and y, right, we start with y is equal to x over x minus 3. When we switch those around, we now have two y terms. We have x is equal to y over y minus 3. And having multiple y terms makes it more challenging. The first thing I'm going to do is multiply by the denominator on both sides so that we don't have a fraction anymore. So now we've got y here, and I'm going to distribute in my multiplication is equal to xy minus 3x. Now, the next thing I want to do is I want to group the y terms together. So in this case, what that means I'm going to do is I am going to subtract xy from both sides. So then both the y terms are over on the same side. So now I have negative 3x is equal to y minus xy. Now the reason that I group these is that I then want to factor, meaning that we're going to factor out a y term, and now we only have one y that we can actually get by itself. So our final step will be to divide both sides by 1 minus x, and you will end up with y by itself, which we know we're done, that's great, and negative 3x over 1 minus x. Now, in terms of our final answer, we could always write the inverse of f is equal to negative 3x over 1 minus x. This is absolutely a correct answer. There is one more, because you could have decided to group the y terms on this side instead, which would give you the very slightly different answer. F inverse of x is equal to positive 3x over x minus 1. So you'll notice that these are just all the negatives are different. So if your answer is everything's the same in a fraction except for all the negatives are different, that's also a correct answer there. Let me know if you have any questions about inverse functions, and I will be available on Zoom and in comments.